Hello everyone, today we are going to talk about skeletal tissues. So skeletal tissue is a type of connective tissue, and, so skeletal tissue, skeleton is made up of cartilage and bone, so it's a special type of skeletal tissue. So the objectives we have to cover are there's different types of cartilage in the body and give examples, describe basic structure of cartilage, identify different types of cartilage under the light microscope, describe the growth, nutrition, and functions of cartilage, state the functions of the bone, describe macroscopic appearance of bovine bone and lamellar bone, describe the microscopic structure of compact bone and spongy bone. In compact bone, identify the following under the light microscope: lacunae, canicule, lamella. How will cell systems work in a canal? Describe how bone obtains its nourishment. Draw and label the parts of an adult long bone in a longitudinal section. Describe the process of endochondral and intramembranous ossification. Draw and label the histological appearance of an epiphyseal plate. Describe the process of bone remodeling. State the common disorders, diseases affecting bone. So if we move to these human skeleton, it's made of axial skeleton and appendicular skeleton. Axial skeleton includes the thoracic cage, that means the ribs and the sternum. This is the sternum and this is the rib cage. So it is inside the thoracic cage. And the skull, cranium and facial bones, and the sacrum and the vertebral column. The sacrum and the vertebral column, and the vertebra, the scapula and the clavicle, and these radius ulnar humerus, and the upper limb and the lower limb, including these pectoral girdle, that is the clavicle and the scapula and the pelvic bone. They all belong to the appendicular skeleton. So only to the axial skeleton that belongs is sacrum, vertebral column including vertebra and sacrum, thoracic cage including ribs and sternum, and the skull including cranium and facial bones. Appendicular skeleton consists of the upper limb and the lower limb, the pectoral girdle and the pelvic region. Functions of the skeletal system are protect internal organs like brain, stores minerals like calcium, potassium, produces red blood cells in the bone marrow, forming blood cells in red bone marrow, and stores fat. Fat is stored in this yellow bone marrow, and it allows movements within these joints and ligaments. Muscles are attached to these joints onto the bones. So they allow movements likewise and also provide support. The mechanical support is provided by the skeletal system. So the skeletal system is composed of two components, two types of connective tissues, cartilage and bones. So cartilages, distribution of cartilages in the human body, we can find cartilages in our nose, in our ear, in these articular cartilages, where the joints articulate with each other. Bones articulate with each other, so they are called joints, and they have articular cartilages, and the costal cartilage, and also the intervertebral disc, and also the pubic symphysis. So hyaline cartilage, fibrocartilage, and elastic cartilage. Hyaline cartilage, fiber cartilage, and elastic cartilage. Structure of cartilage cells, chondroblast and chondrocyte. So chondroblast, they are made of cartilage precursor cells, and chondrocytes, they are made of mature cartilage cells. So chondroblast, they are cartilage precursor cells. Chondrocytes, they are made of mature cartilage cells. Extracellular matrix, it contains collagen, mainly type 1, and elastin fibrous gags. So chondroblasts are made of cartilage precursor cells, and chondrocytes are made of mature cartilage cells. Extracellular matrix contains collagen, mainly type 1, and elastin fibers called gags. Peripheral dense connective tissue layer called perichondrium, usually avascular, or limited capacity repair. Chondroblast. Okay, now we talk about the cartilage. So cartilage is made up of cells and extracellular matrix. The cells in the cartilage are chondroblasts and chondrocytes. Chondroblasts are the cartilage precursor cells, that means they create cartilage. From them, the cartilages are created. They act like predominance in creating cartilages. So the dense layer, the dense peripheral layer, peripheral dense connective tissue layer is known as perichondrium. And chondrocytes are the mature cartilage cells. So after chondroblast create chondrocytes, and at the mature state they are called as chondrocytes. And the extracellular matrix is composed of fibers, and mainly we have collagen type 1. You can see here, this is the extracellular matrix is composed of mainly collagen type 1 and elastin fibers. So elastin fibers, these are little fibers arranged like randomly. Usually avascular, that means no blood supply, so limited capacity to repair. So when the cartilage is damaged, it has a limited capacity to repair again because it doesn't have a proper blood supply, so it's a limited capacity to repair. It also contains these gaps in the extracellular material. So there are three types of cartilages. Based on the nature of fibers. So why there are three types of cartilages? Mainly because of the nature of the fibers. Hyaline cartilage, fiber cartilage, and plastic cartilage. So in hyaline cartilage, clusters of 2 to 4 chondrocytes within the spaces called lacuna, large amount of uniform matrix with few collagen fibers. So you can see this is 2 to 4 chondrocytes exist within the spaces called lacuna. There is a large amount of matrix. You can see the spaces between lacuna. So this lacuna are distantly spaced, and between that there's a large amount of matrix, but there's only few fibers. So you can see that when you stay in this, there are no visible fibers like a mesh, right? So it's only a few fibers, so it's called hyaline cartilage. 2 to 4 chondrites within this space is called lacuna, which are distantly partitioned, and few fibers and large amount of matrix. This is a chondrocyte. This is a lacuna, the space, and capsule of lacuna is the capsule that covers the space, like the outer covering of the space. So these hyaline cartilages can be found in the larynx, trachea, and the bronchial tree. So mainly in the respiratory tract, these hyaline cartilages are found. That's give a reason why hyaline cartilages have chondrocytes, right? And they have a uniform amount of matrix with fewer collagen fibers. So, so they are found in larynx, trachea, and bronchial tree. So, like in the larynx, they have to produce sound, and the trachea is covered with rings functions of cartilages to prevent friction when the food is passing through its pores. And in bronchial also cartilages are found to facilitate the pass of respiratory gases. Then articular cartilages is synovial joints. So there are few synovial joints in our body. We have to Google them out. And then costal cartilages. Costal cartilages is the cartilage between the sternum and the costal part of the ribs. Forms the embryonic skeleton and precursors of developing bone. So in the developing bone and in the embryonic skeleton, hyaline cartilages can be formed. So elastic cartilage, now second one is fibrocartilage. So fibrocartilage, it's got thick layers of dense collagen fibers. It's full of fibers, not a few. It got thick layers of dense collagen fibers. Cartilage matrix with chondrocytes within lacunae are arranged between rows of collagen fibers. So there's an arrangement here, that is that these chondrocytes are kind of like sandwiched between chondrocytes with lacunae are sandwiched between these rows of collagen fibers. So the locations we can find this fibrocartilage, and we call this fibrocartilage because it's full of fibers, thick layers of dense collagen fiber. Its locations are found in the intervertebral disc. So intervertebral disc is the cartilage between these vertebra, which reduces friction between these vertebra and kind of like function them together. And then in the pubic symphysis, so it's a cartilage found between in the pelvic bone, between the two symphyses and menisci of the knee joint. So it's a pad-like cartilage in knee joints and it's called as menisci. So we know that knee joint is an important joint in our limbs. So it's got this cartilage called menisci. So due to this this degradation of this menisci joint, you experience pain, immense pain in this knee joint. So fibrocartilages are found, you can see the densely arranged fibers, layers of fibers, thick layers of dense collagen fibers, and then chondrocytes containing lacuna. Lacuna containing chondrocytes are arranged between these dense fibers layers. Fibrocartilage of an intervertebral disc. So photomicrograph shows this fibrocartilage of an intervertebral disc. Between two vertebra, this can be found. And also in pubic symphysis and in the menisci. Then in the next type of cartilage is elastic cartilage. So as you can see, clusters of 2 to 4 chondrocytes within lacunae. So there are 2 to 4 chondrocytes within lacunae and bundles of branching elastic fibers in the matrix. So this elastic cartilage is composed of mainly elastic fibers. They are in the matrix and they are branched. So these elastic fibers are branched in this type of cartilage, and there are bundles of them. And they have clusters of clusters, like together groups arranged gatherings of chondrocytes within lacunae, bundles of branched elastic fibers. In the matrix. So the location of elastic cartilage is in external ear, and so you can see that nose and external ear and the eustachian tube. In the external ear, the eustachian tube, the tube that connects the pharynx and the ear, the outer ear, and the epiglottis. So epiglottis is a structure in the nasal down the nasal cavity between pharynx and larynx. You can find epiglottis, kind of the structure that separates pharynx from larynx and help the passing of food into esophagus without it going to the trachea by closing the trachea when food is passing. So epiglottis is elastic cartilage, is made of elastic cartilage, and external ear. It's also made of elastic cartilage. As you can see, it's kind of not tough, right? And is eustachian tube, the tube that connects the parings and the outer ear. It's also made of elastic cartilage. So the elastic cartilage is a fluid body is given here. 2 to 4 mitochondrial within the lacunae, and the matrix is full of branched bundles of elastic fibers. And then, yeah, this is an overview of the cartilages, the summary. This is fiber cartilage, elastic cartilage, and hyaline cartilage. In hyaline cartilage, we found 2 to 4 chondrocytes arranged within lacunae, which are distantly spaced from each other. There's a large matrix with few fibers. Hyaline cartilage was found in articular cartilage, costal cartilage, in articular cartilages and costal cartilages, and in nose, and articular cartilages between synovial joints, costal cartilages, and in nose. Let's go back and check it out. Nasal septum, costal cartilages, articular cartilage of synovial joints, larynx, trachea, bronchi, forms the embryonic skeleton and precursors of developing bone. So there's a, this hyaline cartilage is found in trachea, bronchi and trachea, and nasal septum, and even in costal cartilages in articular joints between synovial joints, articular cartilage between synovial joints, and in embryonic skeleton, and yeah, that's all. And then fiber cartilage is like thick layers of dense collagen fibers. Between them, the chondrocytes, the lacunae containing 24 chondrocytes are arranged like sandwiched between the rows of collagen layers. And then the elastic cartilage, it got 24 chondrocytes arranged within lacunae, and there are bundles of branched elastic fibers within the matrix. And then the fiber cartilage is found in the body in intervertebral disc and in pubic symphysis, and in yeah, I believe that's it. Let's go and check it out. Found intervertebral disc, pubic symphysis, and menisci of the knee joint. So menisci of the knee joint, menisci of the knee joint, intervertebral disc, and pubic symphysis. So this is here the vertebral column. It can be mistaken with the trachea, but no, it's a vertebral column, an intervertebral disc, and this pubic symphysis and menisci of the knee joint. An elastic cartilage is found in ear, the external ear, in the epiglottis, and in the Eustachian tube, or the auditory tube. So the disease is associated with cartilages is called as osteoarthritis. It's called common disease. It's a degenerative joint disease that may cause gross cartilage loss and morphological damage to other joint tissues. So morphological damage is more like feature and structural damage to joint tissues. There's loss of cartilage, so mainly the loss of cartilage happens, and then it just causes morphological damage to other joint tissues. The joint tissues are also morphologically affected because of this gross cartilage loss. So it's regularly known as a degenerative joint disease. So collagen matrix of the cartilage gets disorganized and broken down. So the collagen matrix of the cartilage gets disorganized and broken down. Decreased proteoglycan content within the cartilage matrix occurs. So what happens is the collagen matrix of the cartilage gets disorganized and broken down. decrease in proteoglycan content within the cartilage matrix occurs. So in the cartilage matrix, the collagen fibers and the proteoglycan content is affected primarily due to damage from mechanical stress with insufficient self-repair of cartilages. So since cartilage is vascular, it has limited space of repairing. So when mechanical stress is being undertaken, primarily damage of mechanical stress with insufficient self-repair of the cartilages. So it's just damage from mechanical stress is the main cause of it. So there's insufficient self-repair due to lack of blood vessels and damage from mechanical stress with insufficient self-repair of cartilages causes pain and stiffness in the joint. So it's painful and stiffness of joints, and commonly affects the hand, feet, vertebral column, and large weight-bearing joints such as hips and knees. So hips and knees are affected, hands and feet and vertebral column are affected by this osteoarthritis. So as a quick review, I will say again, osteoarthritis is a degenerative disease, joint disease, which causes gross cartilage loss and morphological damage to other joint tissues because of that. The reasons are mechanical stress, damage due to mechanical stress, and lack of self-repair of this cartilage, and commonly found in feet and hands, vertebral column, weight-bearing joints such as knees and hips. It causes pain and stiffness in the joints, and mainly what happens is that cartilage, these collagen fibers in cartilage matrix and the proteoglycan content in the matrix gets disorganized, broken down, and decrease of these stuff happen. So bones, an adult human has 206 bones. We are now going to move to the bones, the skeletal tissue second part, bones. So we'll quickly meet within a break. Thank you.